We found ourselves in 11.2, which are properties of power series. We're going to deal with something called a radius and interval of convergence. So I'm going to give you a few long-winded things, and then we'll get into it. So here's the definition of a power series. A power series has the general form, but that's all we've been doing through chapter 11 so far, where A and C sub k are real numbers. Those are just numbers. The C sub k is a number, the A is a number, right? And X is a variable. The C sub k's are the coefficients of the power series, and the A is the center. We got to have the center down. We got to know where we're centered. It's a nice one when A is 0. Right? 0 is really easy to deal with, but sometimes it's 2, sometimes it's 3. And then the set of values for X for which for which the series converges is its interval of convergence. Do you remember that we were drawing stuff before, like I don't know, maybe like sine of X, so it goes like this. And then we were taking things and going, well, first we got this line. And then we had something that did this, and it got better and better and better and better. There was some interval for which the values would work, that it would actually give us a pretty good approximation. Because I don't think this is a very good approximation here for this point. You know what I mean? That's kind of far away. It's not a good approximation. There's only a small interval, and you'd find out with sine, the only interval you really get would be between negative pi over 2 and pi over 2. Maybe it goes to pi. I don't know. But that's the game. We're trying to figure out where do we actually get a good approximation. And that's what we call an interval of convergence. And then the radius of the convergence of the power series, denoted as big ol' R, is the distance from the center of the series to the boundary of the interval of convergence. So if maybe this is 1, and the interval of convergence goes from 0 to 2, what's the radius? Well, how far is it from 1 to 0? That's 1. How far is it from 1 to 2? It's 1. You know, kind of like a diameter. We think of the interval of convergence as the diameter, the radius of convergence as the diameter, half as big as the interval. And that's where we're going to go with this. Oops. Tried to erase, did something else. All right. Now, how are we going to find these intervals of convergence and these radius of convergence? And there it is. Theorem 11.3. Convergence of power series. Isn't it so nice? We're just reading math right now. It's lovely. But we got to understand it to be able to do anything with it. So it can be centered at some number A, and it will converge in one of 3 ways. Sometimes it'll converge for every single value of X. You can make a Taylor expansion that's going to model that original function beautifully. So it converges for all X, and we could have from negative infinity to infinity. Therefore, the radius would be infinity. Now, sometimes it's only locked in. It's only got a small thing, so the radius is greater than 0. Maybe it's 4. Maybe the radius is 4. Right? You can only go 4 away from the center. To the left and to the right, you can go 4 away. Well, that would mean that your X value needed to be less than R away. And your X value needs to be more than R away from your center, which is A. In which case, the radius of convergence is R. And then we're going to have to do more work to find out if there's an equal sign here. Sometimes there's an equal sign, sometimes there's not. And that's one of the tricks. And then lastly, sometimes it doesn't really do anything. The only place the series converges is at A. Or maybe we're thinking about our center to be 0. Make it a little simpler on you. And then the radius of convergence is nothing. It's just saying, oh no, this is not going to converge anywhere. You can write as many Taylor expansions as you want. The only thing that's going to give it a good answer will be at that point. Kind of like the slope of a tangent line, or the equation of a tangent line, where it only models right at where they intersect. Hopefully some of this made sense. I know I'm 4.5 minutes into a video and we haven't done anything except for read. Let's try a problem. By the way, that's e to the x. The sum is k equals 0 up to infinity of x sub k over k factorial. That's e to the x. Thought I'd just let you know that. Yeah. I think it is. I hope I'm right. Second one wrong. I'm pretty sure it is, though. So we want to find the radius and interval of convergence. Now, the way we're going to do this is we're going to either use the ratio test or we're going to use the root test. Whichever one works best. We'll use one or the two of them. We'll use one or the two of them, so we're going to test for convergence. We did this. This was back in chapter 10. So we look at this and go, hey, what do you think? Ratio? Or should we use a root test? Well, there's a factorial in there, so hey, let's go. Let's go. Let's set this thing up. Remember this little r? Not the same thing as big R, by the way. Well, what is that? That's the limit as k goes to infinity of the absolute value of a sub k plus 1 over a sub k. And our a sub k is the sequence that's inside the series. So we set it up. We're like, okay, the limit is k goes to infinity. And what's our a sub k plus 1? Wouldn't that just be x sub k plus 1 divided by k plus 1 factorial? Now you're starting to see why we did all this nonsense before. Because we can actually use it for something. Now we're going to flip it and invert it, but I'm going to do the x sub k plus 1 is x to the k times x to the first divided by, and I'm going to write this thing out 1 times 2 times 3 times ... k, and then k plus 1. And there's the numerator. Now we're going to invert, we're going to flip this and multiply by it, so we're going to get our k factorial. And I'll do this one in blue just to accentuate. So k factorial, 1 times 2 times 3 times 4, all the way up to k. And then we have our x sub k down below. So our 1s go, our 2s go, our 3s go, everything goes all the way up to k. Those go. Oh, the x sub k's go. The only thing we're left is with x over k plus 1. But wait a second, I forgot to do some... Man, there's absolute values around all of this. And I didn't write my limit. Come on, man. I don't want to stop. I don't want to start this thing back over again. I don't want to listen to me babble on about all that stuff. Oh, man. I don't want to hear it again. I need my limit. This k goes to infinity. I got too excited. So what are we left with? The limit is k goes to infinity, and it looks like we're just left with the absolute value of x over k plus 1. Now, does x have anything to do with k? It doesn't. So what we can do is we can factor out the absolute value of x. I know this was really hard for myself when I was learning this. Oops, to infinity. You're like, what's my variable? K is your variable. X is just your x value. So now we take this limit and we find out it's the absolute value of x times 0, right? That just goes to 0, and we get 0. So our little r is 0, which means that this, what does that mean when r is equal to 0? This implies it converges absolutely. It converges absolutely. Well, what does that mean? It means it works for everything. It means it doesn't freaking matter. So it's kind of strange. The smaller the r, the bigger the interval. And we're talking little r, little teeny tiny r. It says it doesn't matter what this freaking x value is. You can plug in whatever the hell you want to. That's what we're looking for. We're trying to find those values of x that are going to work, that we can plug in, that we can use. And it's saying it doesn't matter. Because it's going to be multiplied by 0 anyway. It's going to go to 0. So this will converge for everything. Our interval of convergence, I'm going to call it IC, is negative infinity to infinity. And then the radius of convergence is infinity. It just goes. We can plug in whatever you want to. So when you use this sum, man, it's going to have a wonderful interval of convergence. And by the way, this is e to the x. Technically, it actually is e to the x. It is It's not even an approximation if you take it to infinity, but when we do it by hand, no way in hell. All right, one more. Sorry that these videos are all like 15 minutes long, but I gotta give you another example. Just want it all in the same thing. All right, so now we got -1 to the k, and let's do x minus 2 to the k all over, let's go 4 to the k. And let's do this one. We want to figure out what's the interval of convergence and what's a radius of convergence. So we look at this and we're like, okay, we got two different choices. We can use ratio or root. Which one are we going to use? Well, they all have a k as the power. I'm thinking root might be good. So to do the root test, we have this little row. I don't know if you remember that. The limit is k tends towards infinity, and we're going to take the kth root of what's going on inside. But come on, man. Oh, I forgot again. It's the absolute value inside of here. It's all absolute valued. Now, what ends up happening with this kth root is it's just going to go thwack, 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 thwack. It's going to get rid of all of those. We're just going to lose all those k's. But it's an absolute value, is it not? It's an absolute value. What's the absolute value of -1? It's 1. So we lose that. What's the absolute value of x minus 2? It's the absolute value of x minus 2 all over 4. Now, remember, root works a little bit differently. If this is less than 1, then we will converge. If it equals 1, bad. If it's greater than 1, bad. But if this is less than 1, we're good. Now, do I need this limit any longer? Where are the k's at? The k's all disappeared. So we're left with just the absolute value of x minus 2 over 4 is less than 1. Well, let's do a little bit of algebra to this. Let's multiply by 4 on both sides and we get the absolute value of x minus 2 is less than 4. And do you know how this works? Do you know how the absolute value is going to work? Where we say it's -4 and +4, and then we trap the interior in there. Do you remember that from algebra? So now we can add 2 and add 2 and add 2. We're going to get -2 is less than x, which is less than 6. So it looks like, well, shoot. We got to be somewhere in between. We're like, oh, the interval of convergence is between -2 and 6. But what about the endpoints? What about the endpoints? Does -2 work? Does 6 work? Because this is only going to give us a less than. But it could be an equal. We're going to have to check it out. So I think this is possibly, maybe, this is the interval of convergence. Maybe. I'm not sure. But what's the radius of convergence? Can you figure out what that is? Can you figure out what big R is? Can you figure out how far away it needs to be from x minus 2 to still work? It's 4. It's just 4. That I don't have to check. But now we need to check our endpoints. So what we're going to do is we're going to check out our endpoints and see if they work. X equals -2. X equals +6. The endpoints. And we want to go back to our original problem and just go take a look. Let's go see what's going to end up happening here. So we're like, okay, so we have our sum from k is equal to 0 up to infinity of -1 to the k times x minus 2 raised to the k all over 4 to the k. And what's our x value? -2. So we check it out and we're like, okay, the sum is k is equal to 0 up to infinity of -1 to the k times -4 to the k all over 4 to the k. Well, we can ignore that negative because since these are both negative values, so say if k was equal to 1, you'd have -1 times -4. That's going to be positive. This is always positive. We could actually just run it over here and be like, no, dude. This is 4k over 4 to the k. Sorry, they're both 4 to the k. So it's the sum from k equals 0 up to infinity of 1. So that's 1 plus 1 plus 1 plus 1 plus 1 plus 1 plus 1 forever. This goes to infinity. This tends towards infinity. That's bad. We don't want that. We want that to go to 0. Those terms do not go to 0. Therefore, -2 is not going to work, and we're not going to use that endpoint. Next, we're going to go through and do the same process again, but we have to do it with 6. Now here, we're going to run through. The sum is k is equal to 0 up to infinity. Now we have -1 to the k times 4 to the k, all over 4 to the k. What's that going to be? Where are we going to get there? 4 to the k's go away. So the sum is k equals 0 up to infinity of -1 to the k. Does that go to 0? Does that limit go to 0? When we take a limit as k goes to infinity of -1 to the k, does that go to 0? No. No. It goes back and forth between -1, +1, -1, +1, -1, +1. This diverges as well. Therefore, x can't equal 6, and thus our interval of convergence truly was -2 to 6, not including the endpoints. Yeah, buddy, that's what we're doing now. We'll do another problem next where maybe it might be a little bit different, and I'll just start off with that, and we'll do just a couple more examples. All right.